Hi, good evening, everyone. And thank you for all for coming here for this demo day. So I'm Vikhyati, and this project that I developed is about like taking shelf photos into making them smarter. They tell you like independent stores like what to do with the shelf photos. They are so cluttered together. So what we're going to look here are the key challenges. What was the motivation behind this project? How did I implement it? What are the results? The live demo about it and the limitations that I faced, and also the future direction where will I go with this project. So imagine you walk into a shelf and you want to buy a television or a Coke, and then you see it's not there, right? And then you're like, "Oh, no, I'm not buying that ever again. I'm leaving this place, right?" That's what you get when you enter a store and you don't find your favorite product. So that was my idea behind it. This is an example of the Life app that is available. So sorry, I think it's left on your end, right? The right image shows an input image that you give to the app, and the other side is the output image that you see. It detects like the gaps. We will see later in details like how it is done. Uh, so why I chose this product? What was my key challenges like that the retails are facing this? So I saw that almost 1.75 trillion revenue is lost in this, right? It's a huge amount, right? Just because of out of stock. And 30% of the consumer are frustrated because they don't find their favorite product. So one of the interesting facts that I realize is that this happens due to in-store failure rather than a supplier's failure, which stores need to work on themselves. And this is the part where like really hit me hard because only 20% of the stores have high tech technologies like robots or hardware system which look at the shelves and tell whether it's available or not. Whereas independent store, which are like 80% of the stores are independent stores like small cafes or a corner shop, which is like not organized, cluttered, and they don't know where their product is. Like they have to do it manually, and it's a one-man job. Whereas in large retail stores, they have a lot of teams sitting there to telling them this is a good product or this is getting out of stock. The solution that I came up with is a product agnostic detection, like using app. What it means, it naturally adapts to the shelf, and it identifies whether a shelf has a gap, or gap means whether a product is out of stock or not. So this is a system overview. So the first step that we do is capture an image from a mobile or the app that I developed. Then the app goes to a quality check layer. Then it checks whether the picture is bright enough or it is like dark, or whether it is like tilted or has an angle. The second, it goes to the model, which is fine tuned on a data set called SKU. And why I chose this data set, because it is like captured like a lot of pictures from all over the world, and it has about like 1 lakh of pictures, tilted at an angle, bright or less. So it covers all the aspects of a retail shelf possible. And then this is where the magic happens in step 4. This is what I developed. So basically, I will talk about it in later slides, but this is where the magic is happening, where it is actually detecting whether there is a gap between a shelf or not. And then these are the last two steps, which is like the final checks it is doing. So we start with the first layer, that is data processing. As I said, that we are using a data set called SKU. And as I already mentioned, we had to convert that. And then you have to normalize it, like put it in 0 to 1 scale. And then it goes into the model. So here the thing is, model only detects the object or a product, but not the gaps, right? So this is my baseline model. So why I chose specifically YOLO, because it's the state of the art of like detecting objects. And why specifically I chose YOLO V8 and not the other model, because it was faster. It required less training time, and it was cheaper than the other models. So, and it could be easily, transferred to mobile or laptop. So it was easily thing. And the reason where like I checked like why the baseline model that is using a cocoa data set, it is just using like it could just perform like about 70%, Whereas like when I fine tuned on the SQA data set, it was giving about 90%. So it is learning the patterns that different shells has. These are some of the results that the model was trained on, and I did it on 50 epochs, and which took around 4 hours, I would say. So the final result was like 90%. It was performing well. So this is some of the picture. Like it is what it is doing is the comparison between like a base model that is a COCO dataset and what it is doing in a fine tune model on SKU. So here you see that the images are like missing some of the product, and it is like not detecting it correctly. Correctly, it is missing some of the values. Whereas when it is trained, it is detecting all the objects possible in the shelf. So this is where I come to picture. This is my core solution. It is called rectangular lattice gap detection. So the idea behind is I will try to make it simpler by giving an example. Suppose there are like 4 bottles of Coke, and like you see one in missing. It's like Coke, Coke, missing Coke, right? So the model detects what it does. It makes into a rectangular grid. So it is basically it's not making a not making a rigid layout. It adapts to the shelf layout. It requires like zero calibration, and it detects the real gap, right? And suppose the second contrast is like Coke, juice, gap, water. So it sees that there's a space between them, and it detects. But it will give a low score because like the products are not same. Okay, let's run into a live demo so that it becomes much more clearer. So this is the app that I built. It's built on Streamlit app, and it is running on Dockerfile. So this is how it looks. So I've just for the demo, I've like put demo images, and these are actual images taken by me, which I went to different stores like Aldi, Lidl, and taking pictures, looking weird. Everybody's staring at me like what this girl is doing, not buying product but taking pictures of the product. Yeah, so it was a weird experience, but yes, I tested my model on real data sets, like going to the myself taking the pictures of DM, little early. So this is like for the demo, I put like some of the pictures, and maybe we'll just look at DMs. Yeah, so I run a scan on this image. It is analyzing like what is the original image. So the thing is, we get an output like it shows an original image, and then we get an image which is detecting the gaps. Can you guys? I'll zoom it first. So see, we see a gap here, right? And we actually see it's like the product is missing. The important part is like I also added some of the new features, like it also detects if the product is pushed back, because you go to a store and like I want to buy vitamin C, but you see no, there is no, it's just pushed back, right? So you just have to pull it manually. So it makes easier, and it also tell if a product is fallen. It's like lying, someone else kept it by mistake, and it's not supposed to be in that column. So this is like the dashboard, which is showing like row-wise detection. Or yeah, it also shows analysis row-wise. Like row 1 is missing 5 products, or row 2 is missing 2 products. So there are different features I try to add. One is like you can upload an image by taking from the live photo, or like for the demo, I just added some demo images. Here you can, make changes to the gap factor. If gap factor means if the shelves are very closely aligned, then you have to make it smaller. If the gap is like the shelves are like far apart, then you make it bigger for better prediction. That's how it works. Yeah, if you guys want to try it, please go ahead. I have made a QR code out of it, so you can test it, go into the save yourself some embarrassment like me, and going to the shelves and taking pictures. Thank you. I'll go quickly here. It's like some of the limitations that I faced. Is it's like if you go to a store and the flavors like different companies have like same, the brand is Coke, but it has like Coke cherry, Coke something, the bottles look similar, right? So that's where I face like there is like it can't identify like if it is a flavor variant or different kind of brand. So that's where I face a problem, like if a shelf has a bigger bottle of air freshener and the other one is a candle, it faces a problem because the candle is shorter and the air freshener is longer. So that's was my limitation. But most of all, it was identifying. This is like what I plan to do with this is like make some model improvements and test on different models, like the state of the art. Like I think YOLO 26 is the latest one. Maybe try on that, how it is performing, whether there is a lot of changes or there's no lot of changes, and maybe try a different, startup programs if anyone is willing and really likes my product. So thank you all for giving this chance.